Hello students, your Jrfsoilcoach is back with the second last chapter from soil physics. If you're watching my video for the first time, please check the playlist above and find more videos from soil physics. My channel is meant for the agricultural students, especially who are preparing for JRF, SRF, ASRB NET and other competitive examinations regarding soil science and physical science. So I will be giving more detailed information and lecture from fundamentals of soil science treatise, introduction to soil science, textbook of soil physics, etc. So welcome to my video. So we can explore water, its structure, the structure of water, structure of ice, etc. So first, structure of water. You all know that water is the most common substance on the earth, which is essential for all the life forms. Its chemical formula is familiar to everyone, H2O. So from the molecule, we can see the water is made up of two atoms of hydrogen and one atom of oxygen. Okay, so hydrogen is here, it is connected to oxygen. So we can explore more details about water. So I will explain the molecular structure of water in detail. We know the chemical formula of water is H2O. That means oxygen is bonded to two hydrogen. So there are two atoms of hydrogen and one atom of oxygen. This hydrogen is covalently bonded to oxygen. Covalent bonding means sharing of electron. So oxygen will provide or it will contribute one electron and hydrogen will contribute or it will give one electron, so they will share two electrons. That makes a covalent bond. So the arrangement of the atoms in water molecule is not symmetrical. So the distance between oxygen and hydrogen is 0.97 angstrom, but the distance between H and H is 1.54 angstrom. If it is 180-degree, the distance between H and H should be around 1.9 something, but the interproton distance is 1.54 angstrom. So from that distance information, we can say that the arrangement is not symmetrical. That means it have a bend shape. They are separated by an angle. That means H and H is separated by an angle of 103 to 106 degree with an average about 105 degree. And the here they are bonded together by using covalent bonding. That means sharing their electron. When two friends share each two friends in share their things each, like H will contribute one electron and oxygen will contribute one electron. That creates a stable pair of electron and they both share it. So this sharing of electron will create a very strong bond. So the entire molecule will be holded with that bond. This is very strong connection, that covalent bond. And the another thing is they have a bend shape, and this is caused by the lone pair of electron that exists on the oxygen atom. Oxygen atom will have a lone pair of electron, so it will push the H away. The bonding electron pairs, that means which is connected to H away, that gives a bend shape. So the angle, sorry. So the angle is 105 degree. Okay, and this is the thing you have to study. That means bond angle, then bond length. OH bond length is 0.97 angstrom. And interproton distance is 1.54, and uh, it is bend arrangement. Then it contains two hydrogen atom and one oxygen atom. Between H and O, there is covalent bonding, and they have a bend shape, the non-symmetrical arrangement due to uneven electron distribution, and of course, this data. So, as a water molecule contains same number of positively charged protons, that means 2H. The charge of H is plus 1, right? And charge of oxygen is minus 2. There is 2 hydrogen, so there is plus 2, while oxygen is minus 2. Uh, that means it have same number of positively charged protons and negatively charged electron, which is contributed from oxygen. So it is electrically neutral. We know that water did not have a charge as a molecule. Some molecule like SO2, SO4, it will have a charge of overall charge of minus 2. Is it sulfate? That means sulfate. SO4 means sulfate, but water is electrically neutral. That means its charge is 0. Okay, so but it is asymmetrically arranged. That bend shape will make unequal distribution of electrostatic charge in the water molecule. That means on oxygen side there will be excess negative charge, while on the hydrogen side there is excess positive charge. So this distribution, uneven distribution of the charges make the water molecule uh, dipole. It will give its dipole character. That means unequal electrostatic charge distribution makes the water dipole or polar character. It will have a polar character. That means the charge will be distributed in one direction. Okay, so uh, look at this picture. This picture is wrong. Sorry, here it should be oxygen. So the between two water molecule, one bond is formed, that is hydrogen bond. That means between hydrogen of one water molecule and oxygen of another water molecule, there is a formation of hydrogen bond. This this link of hydrogen bond, all the water molecules are connected with that link. So these clusters of water molecules are formed. So we can say that water is a polymer of hydrogen bonded molecule of H2O. Then the this linkage is known as hydrogen bond. Okay, so let's look this picture. This is oxygen. This two is hydrogen. So the shape or the space or the size of individual water molecule is largely determined by oxygen ion, because oxygen is very large. It is way larger than that of hydrogen bond, hydrogen atom. So we can say that the space occupied by the water is determined by the oxygen ion. Hydrogen ion take up negligible space, and the diameter of water molecule is 2.64. Study this point. Study this point, 2.64 angstrom. Okay, so it is spherical in shape. Water will occupy a spherical shape. So the things you have to learn from this is water is electrically neutral, but electrostatically it is dipole or polar in character. Oxygen side there is excessive negative charge, and hydrogen side there is excess positive charge. Oxygen, the size of oxygen will determine the size of water molecule. So the diameter is 2.64 angstrom, that is nearly equal to the oxygen diameter of oxygen atom. And the H and O connected together by hydrogen bond. So polymer of water molecule will be formed. So water is regarded as a polymer like structure. So this is the hydrogen bond between the hydrogen of one water molecule and oxygen of another water molecule. So likewise, many hydrogen bonds are formed. So this is one of the this is kind of structure of water molecule. Then the chemical formula of water is H2O. I have already said it contains two hydrogen atom and one oxygen atom. So hydrogen atom will contain one electron in their shell, but Oxygen will have 6 valence electron. That means 1, 2, 3, 4, 5, 6. Okay. But in oxygen there are two lone pair of electron. So the atom in hydrogen and oxygen, one electron from oxygen and one electron from hydrogen will be shared. That forms one covalent bond between one hydrogen and oxygen. Likewise, here also covalent bond is formed. Here is my pointer. Okay. So oxygen have 6 electron in their valence share. It shares an electron with the hydrogen atom. So in this way, four there will be four unbound electrons in its two orbitals. So these bonded and unbonded electron pairs arrange themselves in a tetrahedral shape around the oxygen, which is why the two bonds appear to have a bend shape. So this is the tetrahedral geometry of water. This is the lone pair, non-bonding electron pair. Here 1, 2, 3, 4, 5, 6, 7, 8. So bonding electron pairs, these are the bonding electron pairs, and it will have 4 bonding electron pair and 2 non-bonding electron pair, and it will have an angle of 105 degree. This is a um, picture of water molecule in detail. This is bonded, this is non-bonded pair. Now, both oxygen and hydrogen atom have different electronegativity. Uh, the electronegativity value of hydrogen is 2.1, while oxygen is 3.5. That means oxygen will have high electronegativity. So, both bond are polar. It will have a polarity in this direction. It will pull, oxygen will pull the electrons towards itself. That is the meaning of electronegativity, highest electronegativity of oxygen. So oxygen is more electronegative than hydrogen. So the electron density shift towards oxygen, both of these bond. There will a region is made around the oxygen more negative than the area around the two hydrogen atoms. So here the electron density will be higher. This pulling of electron will be towards oxygen. So water is a polar molecule because its oxygen is strongly electronegative and it will pull the electron pair towards itself, which is away from hydrogen atom, thus acquiring a slight negative charge. The polarity of the molecule depends not only on its constituent atoms but also how they are arranged in the central atom. So the spatial arrangement here, the spatial arrangement means the bend shape of water. So the spatial arrangement of atom will influence electronegativity, not only the type of atom which is present in the molecule. Okay, there is partial positive charge for hydrogen, partial negative charge for oxygen, which is higher. Now we can look the hydrogen bond. What is hydrogen bond? What are its characters, etc. You can say, you can see in this photo between H and O there is hydrogen bond. This is the hydrogen bond. It is strong electrostatic intermolecular attraction between hydrogen atom covalently bonded to a highly electronegative atom. That means oxygen, nitrogen, fluorine, etc. So this hydrogen is covalently bonded to oxygen. Here in the case of water, one hydrogen atom is covalently bonded to the oxygen atom of itself, its molecule. So between this hydrogen and another nearby electronegative atom. So which is the nearby electronegative atom? It is oxygen of another water molecule. So This is a strong electrostatic intermolecular. Intermolecular means between two molecules. This is one water molecule and this is another water molecule. So within the water molecule, there is covalent bond between hydrogen and one electronegative atom, that is oxygen. And between the molecule, water molecule, there is hydrogen bond between hydrogen and the electronegative atom, that is oxygen. It is a strong dipole-dipole interaction. Dipole here, this is a dipole and this is another dipole. It is a strong dipole-dipole interaction, but it is weaker than covalent bond. Here there is sharing of electron. Hydrogen will contribute one electron while oxygen will contribute one electron. So they will share two electron each. And because of this sharing, this covalent bond is very stronger. So this hydrogen bond is weaker than covalent, but it is stronger than van der Waals force. You have studied about different forces, van der Waals force, covalent bond, then hydrogen bond, etc. If you want another video regarding the bond type of bond, you can say, you can comment in the comment box. Okay. So this hydrogen bond, what is the importance of hydrogen bond? It is essential for high boiling point, DNA structure, protein folding, etc. So water will have high boiling point because of this hydrogen bond. It's difficult for breaking the hydrogen bond. So its high boiling point is 100. Many other liquids like alcohol, etc., they will have a low boiling point when compared to water, because they do not have a hydrogen bond. But in case of water, there is hydrogen bond that contributes its high boiling point. Okay. Then we can see uh, between oxygen and hydrogen there is covalent bond, and between hydrogen and oxygen of two different molecules there is hydrogen bond. The hydrogen bond forms between hydrogen and a more electronegative atom or group. Oxygen, nitrogen, fluorine, etc., they are electronegative atoms. So in the case of water, electronegative atom is oxygen. The hydrogen bonding holds the molecules of water so firmly together that the melting point, boiling point, dielectric constant, specific heat, surface tension, viscosity of water is generally higher than those of other compounds of similar or even large molecular weight. So, water will have these kind of properties because of its hydrogen bond. So, at normal temperature, water is a liquid and not a gas because of hydrogen bonding. In soil, structure of adsorbed water on the surface of soil particularly similar to ice. So adsorbed water is very strongly held to the soil. Its structure is similar to that of ice. As this structure is more rigid than that of free water, the mobility of adsorbed water is reduced. We know that adsorbed water mobility is very low. It is because its structure is similar to that of ice. We can say the structure of ice in the coming slides. So in nature, water exists in the form of solid, liquid, and gas, which are called ice, water, and vapor, respectively. Changes of water from one form to another result in the changes of energy. Due to changes in energy, or if we provide some energy or if we take some energy from the uh, substance, the formation or the change in form occurs. That means solid, liquid, gas formation will occur. And then in solid form, that means in ice form, the kinetic energy of water is minimum, but it is maximum in the gaseous form. So the molecules will have greater energy, kinetic energy, or the freedom for the movement in gaseous form. But in solid form, it is rigid. The solid form of water is more rigid, right? It may be due to differences in the rate of motion of molecules in this form. We know that in solid, the movement of molecules is very difficult, but in gaseous form there is freedom of movement. So it is due to the difference in the rate of motion of molecule in this form. When water changes from one form to another, hydrogen bonds are broken or re-established. So considerable amount of energy are required to overcome the transition between these forms. So if we want to make the ice like ice. That means if we want to conserve the shape of ice in its form, like that solid form, we have to provide some amount of energy. Or if we have to maintain that shape, or if we have to make a transition between the forms, we need to provide considerable amount of energy. So the degree of hydrogen bonding of water varies with the temperature and state of water. If we increase the temperature, we the hydrogen bond begins to break. So at 0 degrees Celsius, hydrogen bonding is 100% when the water is in solid state. So we know that at 0 degrees Celsius, some amount of water will occur in the solid state, that is ice, and some amount they will occur in the liquid state. So in the solid state, the hydrogen bonding is 100%. That means there is full hydrogen bonding, but 15% will break when it is in liquid state. That means only 85% of hydrogen bonding is present when the water is at 0 degrees Celsius in liquid state. But at 40 degrees Celsius, that halfway towards boiling, 50% of hydrogen bonding will be there. Half of hydrogen bond will be broken. But 100 degrees Celsius, that means in vapor form, there will be 10% of hydrogen bonding. Some amount of hydrogen bonding will be present. Okay. So next we will see the structure of ice. So water, we know it is a polymer of hydrogen bonded molecule. So this is the bond between two water molecules weaker than the covalent bond between hydrogen and oxygen within the molecule. So we can say that water will not have a rigid structure because this hydrogen bond can be broken any time. But comparing to the water, ice will have a rigid structure. The structure is like this. There will be empty space. There is hydrogen bond, there is covalent bond, but it have hexagonal crystal lattice. Hydrogen bonds are constantly being formed large empty spaces. This is the description. But in liquid water molecule, the molecules are in constant random motion. Hydrogen bonds are constantly being formed and breaking up. There will be formation and breaking up of hydrogen bond simultaneously. But in ice, the hydrogen bonds are formed. There is no breaking. So it will have a rigid structure. So you can see in the water molecule, uh, this is the structure of ice. So one water molecule is bonded to four water molecule. Like see this hydrogen bond. It is surrounded by one, two, three, four, four molecules of ice or molecules of H2O. So it forms empty space inside. So here in ice, remember there is four hydrogen bonds in ice. Okay, that gives a tetrahedral arrangement of atoms in ice. So these are vacant spaces. One water molecule is linked to four neighboring water molecules. This is a speciality of ice. It creates a open hexagonal lattice structure. So what is a shape of ice? It is open hexagonal lattice structure. Loose hydrogen bonds between continuously moving water molecules at 10 degrees Celsius. This is liquid. But in ice, there is strong stable hydrogen bonds between water molecules at 0 degrees Celsius, forming a rigid hexagonal crystal lattice structure with a lot of open space and large gaps between molecules which held rigidly apart. So the it is a 3D lattice structure of ordinary ice in the refrigerator. So when comparing water and ice will have a rigid structure. So we can see the melting of ice. So next we can see the melting of ice. So what happens during melting of ice? So during melting of ice, We know when we apply or when heat is applied, ice gets melted. It gets melted to water form, liquid water form. So at this time, what happens is that we know the bond length between oxygen and hydrogen is about 0.97 angstrom. So during melting of ice, the hydrogen bond gets stretched, and due to this stretching of hydrogen bond, the length average length of this hydrogen bond becomes 2.9 angstrom. So the hydrogen bond stretch to approximately 2.9 angstrom. The next change is that you can see the cages. This is the structure of ice. It is closely packed. So during melting, hydrogen bond breaks, and due to this breakage, the neighboring water molecule, free water molecules, can enter to this space. So what happens is that additional water molecules enters to the intermolecular space between the in the molecule. There will be some space. To that space the water molecules enter. Next one is a change in the density. In ice, one molecule is surrounded by four atoms, but in liquid water, hydrogen bond breaks, and one molecule is linked to more than four neighboring atoms. That's why the closer packing happens, and water becomes more denser than ice due to its decrease in volume. That is a real reason for why ice float in the water, because ice is less denser than water. Then due to absorption of energy, it will not raise the temperature, but it increases the potential energy of molecule, and with that potential energy increase, the attractive forces between molecules will be overcome came, and it holds the attractive forces between the molecules in the ice. It will be overcome by the increase in the potential energy due to the absorption of some energy. So the liquid water molecule will have a greater potential energy when compared to ice due to absorption of some amount of energy, that is 80 calorie per gram of heat energy. So during the change from solid to liquid state, 80 calorie per gram is absorbed. It will not increase the temperature of the system, but it increases the potential energy of molecule. And that 80 calorie per gram, it is known as the latent heat of fusion. So when a substance is changing its phase from solid to liquid, then latent heat or comes into action. That means from solid to liquid, it is known as latent heat of fusion. That is 80 calorie per gram. It will not increase the temperature. That means temperature becomes constant, but heat supplied, it will be 80 calorie per gram. It increases. The heat supplied increases, and the amount of heat received by solid body to transform into liquid without raising the temperature of the substance is known as latent heat of fusion, which is 80 calorie per gram. Then latent heat of fusion is related to the solid liquid phase change. But when liquid is changed to gas, there is latent heat of vaporization. So here temperature remains constant as liquid turns to gas. Well-regulated structure of ice is not totally lost in the liquid water. Some crystalline properties are maintained in the liquid state at temperature much higher than the freezing point. The polarity of hydrogen bonds makes a crystalline structure of liquid water, but this structure is not so rigid and permanent like ice, but more flexible and transitory. So, while melting of ice, that rigid structure is not totally lost. some crystalline properties will be maintained because we know that some hydrogen bonds will be there. Then polarity and hydrogen bonds will make the crystal-like structure of liquid water, but that structure is not rigid and permanent. But in ice, that structure of ice is rigid and permanent. And but in liquid water, it is more flexible and transitory. Despite these, the structure in the liquid state of water is sufficiently stable, and clusters of water molecules behave in some respects like single large molecules. Only in the vapor state, water molecules completely lose their intermolecular hydrogen bonds. So, in vapor state, we know that 10% of hydrogen bonds is there. And when we increase temperature and more vaporization occurs, they completely lose their intermolecular hydrogen bonds. So, this is all about the class of structure. To like, share, and comment. Subscribe my channel for more videos. Thank you. Have a nice day.